1, we know that y equals to gx equals to minus 1, 1x is greater than 2 and equals to minus x plus 1, 1x is from 1 to 2 and equals to 0, 1x is from 0 to 1 and equals to 2, 1, x is smaller than 0. So we can know that y is bounded between minus 1 and 2. So we can directly write the distribution function of y when y is greater than 2, and this should be 1, and y is smaller than minus 1, and this should be 0. And for the values of y between minus 1 and 2, we know that 1 y is equals to minus 1. This time x is greater than 2. So the probability of y equals to minus 1 is equals to the probability of x greater than 2, and it equals to 1 minus the distribution function of x at x equals to 2. And when y is equal to 0, we know that x is between 0 and 1. So the probability of y equals to 0 equals to the probability of x is between 0 and 1. It's equal to the distribution function of x at x equals to 1 minus the distribution function of x at x equals to 0. And let me make these two parts smaller. And the next case is that when y is from minus 1 to 0, we know that in this case y equals to negative x plus 1 and x is from 1 to 2. And here we can apply the fundamental theorem to calculate the density function of y. And here is the formula. So we can directly put in the value. So here x is equals to 1 minus y. So here we got the density function of y equals to the density function of x. The value is 1 minus y. And here we have derived all case of y with respect of this density function from y equals to y smaller than negative 1, y equals to negative 1, y is from negative 1 to 0, y equals to 0, and y is greater than 2. We have not get the value of y is from 0 to 1 because y cannot be 0 to 1. according to the gx. So here we can write the summary of density function of y. It is equals to 1 minus the density function of x at x equals to 2, and this time y is equals to minus 1, and it equals to the distribution function of x of 1 minus 1 y when y is from -1 to 0, and x equals to, we just put the summary of what I get in the above calculation. Otherwise, y, the density function of y is equals to 0. And here we derive the distribution, we derive the density function of y, and let me put it smaller again. And so based on this density function of y, we can directly calculate the distribution. We can directly calculate the distribution function of y. And it is just the integral of density function. And here we need to pay attention to the case that when y is from -1 to 0, because the integral of this one cannot be easily calculated. So the density function of y, when y is from -1 to 0, we should use another method to calculate it. And here I use y equals to probability of y smaller than y, and plug in the value of gx. We know that it equals to negative x plus 1 smaller than y, and rewrite it. It is equals to 1 minus the density function of x at x equals to 1 minus 1 y. And let me also put it smaller. So that when I write the summary, I can refer to the previous calculation. So based on what So based on what is calculated above, we can write the density function of y it is equals to 0 when y is smaller than -1, and it is equals to 1 minus this one, as stated here, when y is from -1 to 0, and it is equals to 1 minus the density function of x at x equal to 0 when y is from 0 to 2, and it equals to 1 when y is greater than 2. And here I would like to talk a little about when y is from 0 to 2, the density function is a constant value, because as we can see from the density function of y, when y is equals to 2, it equals to the density function of x, the distribution function of x at x equals to 0. And we know that the based on the probability of distribution function, it should be equals to 1 when y is greater than 2. And so here we just, when y is from 0 to 2, we just use 1 minus the value of density function at y equals to 2. So here we got, this is how we get this value when y is from 0 to 2, because in the another part of 0 to 2, the density function of y equals to 0. And so here, based on what we have derived, we can draw the distribution function and density function of y. And based on what is given in our problem, we know that the distribution function of x, and so y, the distribution function of y should be here. We see an impulse here, and this is from y equals to -1, and here we see it should be the density function of x at y from it, and replace x with 1 minus 1, so we got this value. And at y equals to 0, it should be another impulse, and at y equals to 2, it should be also an impulse. So here is the density function of y, and the distribution function of y, we can just, it equals to 1 when y is greater than 2, and it should be 0 when 1 is smaller than -1, and it should be an integral, and when y is from 0 to 2, the density function of y is equals to 0, so there should be a horizontal line, and at y equals to 2, there is another impulse, so it directly jumps to the value of 1, and this value should equals to the distribution function of x at x equals to 0. And so here we got the distribution function of y and density function of y. So here is the problem 1. So for this problem, we should know that use the property of density function equals to 0 and the max density function equals to 1, and we should try to use the fundamental theorem, also the probability, to calculate the density and distribution function.